Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about the types of probability distribution like Poisson, binomial, and nominal. So, very first thing is that frequency distribution. So, it is the listing of observed and actual frequencies of all outcomes of an experiment and that actually occurred when experiment was done. And probability distribution is that, so it is the listing of probability for of all possible outcomes that could occur if the experiment was done. So normally this can be described as a diagram or a table, or it may be a mathematical formula. So distribution will be of two types. So just know what I said, that should be frequency distribution. It is nothing but the listing of observed and actual frequencies of all outcomes of an experiment that occurred when experiment was done. And probability distribution means it is the listing of probabilities of all the possible outcomes that could occur if an experiment was done. So it can be described as a diagram or a table, or it may be a mathematical formula. So the probability distribution will be of two types. So like discrete probability distribution and then continuous probability distribution. Again, the discrete possibility distribution will be of two types like binomial distribution and then Poisson distribution. So whereas this continuous distribution like normal distribution. So the probability distribution will be of two types. So discrete probability distribution and then continuous probability distribution. This discrete probability distribution will be two types like binomial and then Poisson, and continuous will be one of the type like nominal or normal distribution. So what is this discrete distribution and continuous distribution? So discrete distribution means a random variable, so that can take only limited number of values. And example is that, so the number of heads in two tosses. Continuous distribution means, so it should be a random variable that can take any value. So example, height of the students in the class. So the discrete distribution means it should be a random variable that can take only the limited number of values. Example, number of heads in two tosses. And continuous distribution means random variable that can take any value. So example, height of students in the class. So these two are the two kinds of probability distribution. Tree diagram. So a fair coin is tossed to twice. So how we are going to construct this tree diagram. So suppose a coin is going to be tossed twice. So initially I'm going to have head and then tail. So again, another option is that, so the second coin I can able to get head or I can able to get tail. Suppose if the first coin is head, again I can able to get head or I can be able to get tail. So the possible outcomes will be this. So finally we are going to have four options. Then how are going to calculate this probabilities? How can able to do that? So for this, so initially how to calculate uh, out of these two. So first I have to calculate 1 by 2 is the probability and second one is under 1 by 2. So probability of getting tail is 1 by 2, probability of getting head is 1 by 2. So similarly in this second one, so I'm going to get uh, probability of getting this is second coin, probability of getting head is 2, and then probability of getting tail. So here also the probability values for all this would be 1 by 2. So now what is the probability of getting both our heads? So that should be multiplied by 1 by 2 and 1 by 2. So that should be 1 by 4. And similarly, probability of getting one head and one tail, that should be 1 by 4, and all the probabilities that should be get is 1 by 4. So independent event means that so one spin that has no effect on the another spin. So both are the independent one which should not be dependent on another. So that event should be treated as a independent event. So calculating the probabilities. So probability of obtaining at least one head. So what are the probabilities we're going to calculate? Probabilities we're getting and obtaining one head like that. So if we look at this, so these are the four possible outcomes. So out of this, at least one head means I'm going to get only these three events. So this will not be considered. So the sum of all these probabilities, that should be the output of the probability of getting one head. Similarly, suppose probability of obtaining at least one tail, so that should be treated as same thing. So in this case I can able to get these three, so 1 by 4 plus 1 by 4 plus 1 by 4, 3 by 4. Probability of getting two heads, so that should be 1 by 4. Probability of getting two tails, 1 by 4. So like this we are going to calculate the probabilities of different events. So next one is the discrete probability distribution. So tossing a coin three times, so that should be represented as, suppose I am going to have three coins initially facing three heads. So what are the other coins that if we are going to toss three times, what are the possible outcomes I'm going to get? It is so one head, two heads and one tail, and one head and two tails, and tail. Another one is two. So these are the possible outcomes I'm going to get. So totally I'm going to get 8 possibilities, right? So the probability where x is the event, so that should be represent number of heads. So the probability of obtaining one head, zero head, so that should be only one frequency, that should be this one. So what is the probability this? So 1 by 8. And next one is that probability of obtaining one. So what is the frequency? 3. So one head is where I'm going to get it here is that uh, these three cases. So in these three cases, what I'm going to do, so I'm going to get three positive frequencies, so I'm going to get 3 by 8. So similarly next one, so I'm going to get 2, probability of getting 2. So in this one, so what I'm going to say is, so probability of getting at least 2 heads, so 1, and this is the one of the case, and this is another case, and this is another case. So totally 3 frequencies. So I'm going to get 3. So probability is 3 by 8. Probability of obtaining all the 3 heads. So this is the only one case. So 1. Totally the probability is 1 by 8. So these are the probabilities for finding an experiment. So based on the uh, question. And next one is binomial distribution. So in the binomial distribution, there should be certain phenomena in nature which can be identified as Bernoulli's process. So what is this? In this one, so there should be a fixed number of trials carried out, and each trial has two possible outcomes, that may be success or it may be failure, or it may be true or false, etc. and the probability of occurrence of any outcome remains same over the successive trails, and these trails are the statistically independent. So binomial distribution is the discrete probability distribution which can be expressed as the probability of one of set of alternatives, so like success and failure. And if I'm going to write a probability of x is equal to x, so that should be NCR p power r and q power n minus 1. So this is the binomial distribution. So binomial distribution means it should be a certain phenomenon in nature where you can able to identify it as Bernoulli's process, what we call. So in this process, there should be certain constraints. So like there should be a fixed number of trials carried out, and then each trial should be have possible outcomes that may be a success or failure, and or I can able to write it as the true or false. And the probability of occurrence of that any outcome remains same over. And these trials are statistically independent. So binomial distribution means that there should be a discrete probability distribution. So where you can able to express the probability of one of set of alternatives like success and failure, and where you can able to represent the equation as NCR q power r and q power n minus 1. So where n should be the number of trials undertaken, and r should be the number of success desired, and probability of success and probability of failure. So four coins are tossed 160 times, and then following all the results obtained. So the number of possible heads is that 17 frequency. Possibility of getting one head 52 frequency, 254, and then 331 and 446. So for this, how can able to fit this into binomial distribution data? So let x should be the event. Uh, So obtaining by using this data, I can able to estimate the binomial distribution. How are going to fit it by defining the function. So fit the binomial distribution and the assumption that the coins are unbiased. So at the time, what is the case? And next one is that Poisson distribution. So Poisson distribution means whenever there is a large number of trails but a small probability of success, the binomial calculation become impractical. So that means there should be an equation like lambda. So that should be the mean of number of occurrences of event per interval of time by space, and the probability that will be occurred exactly is going to be given by the equation of this way. So probability of x is equal to lambda power x into e power lambda by x factor. Poisson distribution. So here lambda equal to the mean of the occurrences of the event per unit interval of time by space. Then the probability should be given by this as, so probability of x is equal to lambda power x uh, e power minus lambda by x factorial. So where e should be called as Nampere constant and e value is this one. So here in probability distribution, there should be a large number of trials and but a small probability of success. So the binomial calculation becomes impractical. So this, according to the Poisson distribution, so we're going to have equation like this. So lambda power x into e power minus lambda by x factorial. So where lambda should be this and the number of occurrences of the event per unit interval of time, and the probability of occur of x times is given by this equation. So where e called as an Ampere constant and that value is this one. So what are the characteristics of this Poisson distribution? So it is a discrete distribution and occurrences are going to be statistically independent one, and mean number of occurrences in any time of proportional to the size of the unit should be, and we have to be the mean of the Poisson distribution lambda equal to np, and standard deviation according to the Poisson distribution is that lambda of x is equal to square root of lambda is equal to square root of np, and it should be always right skewed. And the Poisson distribution is a good approximation to the binomial distribution whenever the n value should be greater than or equal to 20 and p value should be less than or equal to 0.05. So the some of the characteristics of the distribution is that so it should be a discrete Poisson distribution, and mainly it is going to be occurrences are statistically independent, and the mean value of the Poisson distribution is lambda equal to np, and the standard deviation is square root of lambda is equal to square root of np. So in nominal distribution, the mean value should be xi into pi, and variance is equal to xi minus mu into pi, and standard deviation is equal to xi minus mu whole square. So this should be according to the nominal distribution, and this should be the Poisson distribution. So what is this nominal distribution? But it should be a Poisson, continuous Poisson probability distribution. So that is the random variable can take any number of value within the given range. So example height, weight, and then marks. And it should be developed by the 18th century mathematician astronomer called Gus, what we call as a Gaussian distribution. So it is somewhat symmetrical and unimodal, and since it is symmetrical, so its mean, median, mode coincides all the three same, and the tails of this asymptotic to horizontal axis that should is so the curve goes to infinity without touching the horizontal axis. So here the x-axis is going to represent the random variable like height and weight, and y-axis represent the probability distribution. So the area that under the curve tells the probability here, and the total area is 1, or it should be 100%. And according to the mean, it should be represented as mu, and standard deviation should be as sigma. Okay, so these are the some of the concepts that should be regarding the nominal distribution. So it should be continuous probability distribution is the one thing, and here mainly the random variable can able to take the value within a given range, and this should be developed by the 18th century mathematician, and it should be a symmetrical and unimodal approach. Since it is symmetrical, its mean, median, mode should be coincides, and here x-axis represents the random variable and y-axis represents the probability density function, and the total area under the curve is that 100%. So defining a normal distribution, so here only two parameters are going to be considered, mean and the standard deviation. So in this mean and standard deviation, it should be same, or it may be different, or different means and different combinations may occur. So if I have two parameters are considered according to mean and standard deviation, there should be a same mean and different standard deviation, and same standard deviation, different means and different means and different standard deviation. So these three possible outcomes may appear in normal distribution. Suppose if I am going to construct a nominal distribution curve, so the area that comes under this curve should be treated as the probability. So what I'm going to say that is, so if I'm going to take a graph, in this graph, so the area that comes under this curve should be the probability, and this should be the mode and median in between them, and z-score values are going to take along this. So what is this 68, 95, 99.7% rule? So this is the graph is going to obtain. So most of the data should comes under this 60% of the data. So and the green margin, what we call, should be 95.5% of data, and blue to blue that should be treated as 99.7% of the data. So the area that under curve should be main thing. Based on that, we're going to estimate the percentage of data according to the rule 68, 95, 99 rule. So normally the area under the curve should be of three things. So the mean value should be plus or minus 1, Then standard deviation covers approximately 68% of area, and mean value should be plus or minus 2. Then standard deviation is able to cover 95% of area, and if it is plus or minus 3, then it should be covers 99.9% of area under the curve. So these are the three different areas what I'm going to be calculated in this one. So whenever the mean value is plus or minus 1, so the standard deviation is going to cover 68% of area, and the mean value is plus or minus 2, then it should be 99.9%. And if the mean values lies between 3 and minus 3, then I can able to get 99.7% of area. What is this standard nominal distribution? In standard normal distribution, the mean value should be 0 and standard deviation should be 1. So in standard nominal distribution, the z value is going to be calculated as, so z is equal to x minus mu by sigma, where z should be the number of standard deviation from x to mean, also called as z score, and x value should be the value of R. So in standard deviation, we're going to calculate the mean value, and then we're going to be estimate the standard deviation should be 1. So we're going to have number of standard deviation should be calculated by according to z. So what we called as z score, and mean x minus mu value by sigma. This is the equation we have to be remembered here. So that should be about the different types of probability distributions. So in this one, so we're going to first calculate frequency distribution and probability distribution. So frequency distribution is nothing but a listing of all observed and actual frequencies of all outcomes of an experiment, whereas the probability distribution should be the listing of all the probabilities of possible outcomes. So that should be occur if an experiment was done. So this thing should be represented in the form of a diagram or table or mathematical formula. So this probability distribution will be of two types, right? Discrete probability and then continuous probability. So again, the discrete probability is further two types, like binomial and then Poisson. And continuous probability distribution means it should be normal distribution. So what is this discrete distribution? So the random value can take only limited number of values, whereas continuous distribution, the random value can take any value. So if I'm going to construct a tree diagram for this, fair coin is going to be tossed 2 times. So for that, what I'm going to say is, so initially I have to toss one coin. So I'm going to get head and tail. So for the first option, what is the equation of the second coin, and what are the options I'm going to get on the second coin for the option 2. So the possible outcomes is going to be measured, and then we have to calculate the probabilities, which should be the product of this two events, and the independent event should be that. So where the first spin should be entirely different from the second spin, and we have to calculate based on the questions like probability of obtaining only one head, that should be the summation of these values, and tossing the 3 coins at a time, that should be also one of the example I told. So obtaining x should be the number of heads of obtaining zeros, 1, 2, and then 3. So the binomial distribution is going to be a discrete probability distribution where I'm able to calculate based on the equation like probability of x is equal to x. So that should be defined as NCR p power r into p power n minus r. And Poisson distribution means, so the equation given by Poisson distribution is p of x is equal to lambda power x and to e power minus lambda by x factorial. So where lambda should be the number of occurrences of an event, so within a unit interval of time, and where e should be called as an empire constant, that should be equal to 2.7. And Poisson distribution characteristic should be, it should be a discrete distribution, and it should be occurrences and statistically independent one, and mean of this standard Poisson distribution is lambda equal to n into p, and then standard deviation would be defined as square root of n into p. So nominal distribution is a continuous probability distribution. It is entirely different from a previous one, and then it should be a symmetrical any-model approach. And the tail is also going to be asymptotic to the horizontal axis, and the x-axis is going to present the random variable, and y-axis is going to represent the density function. So the area that under the curve should tell us the probability how much it is. So normally it should be equal to 100%. And if I'm going to say this, so we're going to able to calculate the mode, median, and then values. And this by seeing this 68, 95, 99 rule, so the most of this data, the mean value if lies between plus or minus 1, then it should be 68% of data. So if the mean value should be lies between plus 1 and minus 1, so plus sorry minus 1, minus 1 and plus 1, minus 2 and plus 2, and minus 3 plus 3. So if the mean values lies plus 2 and minus 2, then I can able to get 95.5% of data, and there should be 68% of data. And in between this minus 3 plus 3, I'm going to get 99.7% of data. So based on the area, I can able to segregate it. A normal Poisson distribution. So here it should be mean should be 0, standard deviation should be 1, and this I'm going to calculate the Z score value. So the Z score should be defined as x minus mu by c. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.